Identify subsets and proper subsets using set notation. All right, so let's talk about a subset. A subset of a set W is another set that contains only elements of W, but it may not contain all elements of W. So a subset can simply be anything that has some or all elements of the original set. Now, if we would say E is a subset of W, then it can be written as E is a subset of W. So it's kind of got this interesting symbol that shows subset, right? So it just means subset. Okay. Now, a proper subset is a subset that does not contain all elements. So if we think about, let's just say our set is 1, 2, 3. A proper subset might just be 1 and 2. 1 and 2 exist in the initial set, but it's not all of them. So this is a proper subset. So if M is a proper subset of X, we would write that as M is a proper subset of X. So you can see with just a subset, we have like this equal sign underneath the sideways thing here. And with it just being a proper subset, we have that, just that simple. Okay, so consider the following sets. We've got A, B, C, and D. Let's use proper set notation to show the relationship between sets. Okay, so this is fun. This is a lot of fun. So first, let's just notice that A is the set of 2, 4, 6, 8, 10, 12, and it goes on and on. So this is an infinite set that deals with even, positive even numbers here. B has 2, 12, 22, and 32. Well, all of those that are in B are also in A. So B is a proper subset of A. Absolutely. And if you look at C, it has 2 and 12. Well, C is a proper subset of A, and C is a proper subset of B, because you can see B has 4 elements, C only has 2 elements, but they are all part of B as well. And then we have D, which is 8, 10, and 12, so D is also a proper subset of A. So very exciting how we have some different sets and how they are related. Let's look at another one. We have E, F, and G. Again, we're going to use proper set notation to show the relationship between sets. So E has 4 elements, 8, 14, 20, and 34. F has the elements 8 and 20. Well, I noticed just as I said those, that 8 and 20 in set F, that would make F a proper subset of set E, because 8 and 20 are both elements of E, but it's not all of the elements. Now, when I look at set G, I have 34 and 42 as my 2 elements. Now, 42 is not an element anywhere else. So because the elements in G do not exist in anything else, G is not a subset of anything. And because all the other elements, none of them also fall in G, that is just a set that is just here for looks. And the only thing we can say is that F is a proper subset of E.